I have a new stylus. You can, oh, that's not what that says. You can multiply two square roots together. My handwriting will get better, we hope. Here's an example of that. And you guys kind of did this yesterday, but you did the opposite direction. So you guys took a square root and you split it up. So today, you can take, for example, square root of 2 times square root of 10. That would be equal to the square root of what? 20. Yeah, so you take the two square roots, you multiply them together, you multiply the numbers on the inside. First example. So we multiply these square roots together. 21 times 3, what would that give us? 63. I like this one better. And now we need to simplify that one. So think back to yesterday. We need the highest perfect square that 63 can divide by. We're looking at 4, 9, 16, 25, etc. What's the highest one? 9. So we break this up into 9 times what? 7, okay, which we can write as 2 square roots. If you want to go straight to that step, that's fine. What's the square root of 9? 3. So 3 root 7. So same thing as yesterday, largely, but you need to go ahead and multiply first and then simplify. So we have 2 square roots multiplied together. We can multiply what's underneath the radicals. Multiply the numbers, what we have? Square root of 20, and then x times x is x squared. Good. Square root of 20 is not a perfect square. So you need the highest perfect square that 20 divides by. What is it? 4. So we're going to split this up into 4 times 5x squared. Okay, perfect squares here. 4 is a perfect square. What else is a perfect square? X squared. And so we're going to take out, we're going to put these two things in a radical by themselves. You might be able to do it without this step, and that's fine. But 4x squared, those are perfect squares. The square root of 5 is not. So square root of 4 is 2. Square root of x squared is x, and then root 5. We would say you can split up a fraction into 2 square roots. So if there's 2 numbers in a fraction underneath the radical, you can split it up. Be something like this. If I have the square root of, I don't know, how about square root of 3 over 100. We can rewrite that as square root of 3 divided by square root of 100. Square root of 3 can't be simplified. It's not a perfect square, so you leave it like that. But what's the square root of 100? 10, so it'd be square root of 3 over 10. That would be your answer there. Okay, so we'll split this up into 2 square roots, into the square root of 16 over the square root of 81. And those are both perfect squares. What's the square root of 16? 4. Square root of 81? 9. Leave it as a fraction, 4/9. Split this one up into 2 square roots. Can you simplify the square root of 5 any further? Nope, that's it. So we'll leave that one. But what's the square root of 49? 7. These are both perfect squares, so it will work out nicely. What's the square root of 4x squared? 2x. 2x. And the square root of 144? 12. The square root of 4x squared is 2x because 2 times 2 is 4, and x times x is x squared. But this is not done. Can we simplify that? 2 over 12. What can 2 and 12 both divide by? 2. So you need to do that. So really you get 1x over 6, which looks kind of weird. Do you really need the 1 there? Nah. So we're going to put x over 6. Okay, 4 over root 7. We don't like this. We're not allowed to keep a square root there. And so you have to rationalize the denominator. What you do, basically whatever square root is in the bottom of the fraction, as long as it's simplified, you multiply by that on the top and the bottom. Because what's the square root of 7 over the square root of 7? What's that fraction equal to? 1. You're just multiplying by 1. So you're not changing anything, really. Okay, so we multiply. This would be 4 root 7 on the top. And then on the bottom, what would I have? Square root of 49. This is not a coincidence. You're going to see that the bottom of the fraction, the denominator, just goes to 7. So those square roots like cancel each other out, basically. So your final answer would be 4 root 7 over 7. You cannot have a square root or a radical in the denominator. Okay, we don't like this because there's a square root in the denominator. What should I multiply by? Yep, the square root of p on both the top and the bottom. When we do that, on the top you get 2 root p. What do you have on the bottom? Square root of? What's p times p? P squared. And the square root of p squared is b. So those square roots cancel each other out. You'll probably be able to do this without that middle step eventually, because these two things right here, these square roots cancel each other out because you're multiplying 2 of them together. Okay, so that's your final answer. We split this up first. Check it. Can the square root of 3 be simplified any further? Can the square root of 50 be simplified? Yes, it can. What's the highest perfect square that 50 can divide by? 25. So you don't want to multiply by square root of 50 on the top and the bottom, because then you just made your life a lot more difficult. So we're going to simplify this first. This is the square root of 25 times the square root of 2. And so really, this is equal to square root of 3 over, what's the square root of 25? 5, so 5 root 2. You still have a radical in the denominator, and that's not allowed. So what should I multiply by on the top and the bottom? What do you think, Jackson? Do you have a question? What could I multiply by to get rid of the square root of 2? Square root of 2. You just multiply them by itself. Technically, you could multiply by something else, but it works out the best if you do it this way. So on the top, you are going to multiply those together. Square root of 3 times square root of 2 is square root of 6. And on the bottom, you have 5 just stays out front. The normal numbers are multiplied together, the constants on the outside. And square root of 4, because it was 2 times 2. Okay, you're almost done. What's the square root of 4? 2. So this is a square root of 6 over 5 times 2. So your final answer is the square root of 6 over 10. 6 cannot be simplified any further. Okay, you do need to simplify square root of 63. It simplifies into 3 root 7. And then you rationalize by multiplying by the square root of 7 on the top and bottom, which would give you the square root of 42 over 3 root 49. Which, since those square roots cancel out, you just end up getting 7. So it's the square root of 42 over 3 times 7. Final answer is this. No, you cannot divide 42 divided by 21. Because 42 is in a square root and 21 is not, you have to leave them separate.